So now that I've run the transmission through the box, we now have our two files, RxOFDM faces and office. And before I actually run the code to decode those, I would just like to talk about what I've done so far. So on the receiving code, again this is based on Tim's code, and there's essentially three methods that I attempted to try in order to do this. If we bring up the diagram of the reception, which is here. So as you can see, when an image comes in and it's decoded, the cyclic prefix gives us a coarse tune, and the sum of the imaginary parts of the pilots give us a fine tune. Now I want to do a live reception, semi-real time. What I mean by that is that I don't want to make multiple passes throughout the image. I want to go through it once, and as I'm going through it, I want to decode and retrieve some of the data. So as a symbol comes through, we extract information from it and use that to tune this delay, which will affect in turn the next symbol. So in order to do that, we needed to do some cyclic prefix detection using cross correlation. And if we go back to the code here, initially I just did it for the first symbol so we could get our rough symbol start. And if we go down to the pilot sums, you can see here instead of skipping the pilots, which was originally done in the code because they were useless, we're actually summing these up. And I have a little algorithm here which acts on the pilot sum total. It changes a value called fine offset. And now this can either increment it or decrement it depending on the condition satisfied. And fine offset up here defines the symbol start and symbol end from when we take out the symbol from the received data. So this in effect adds a delay or advances a step. So if we just give this a run, we should hopefully get a reception. Now also in this code I have just a little few lines that work out an approximate bit error rate. So we'll be able to have an objective measure of how accurate the reception was. Yep, and that's because I put the wrong one in. So if I change this back to gray T, and I take these out because we really only need this here. And it's a PNG. So this should just run through and hopefully we should get a decoded image. So here we go. And we can see down here we have an error rate written on the command line of 71%, which in turn means we have 29% of the image decoded, which is over a quarter. And if we just maximize this, we can see we have a relatively decent reception. You can see the outline of both the people's bodies, and in particular down here there seems to be a nice big chunk, and running up here, of properly decoded images. Now I would expect to see lines like this completely horizontal, which is kind of what we're getting. It's very rare that we just get little isolated bits, because to me that is just random, where this is what I've expected to see. This is by design. So to me this says it as a relatively successful. It's not ideal, it's only 29%, but it is a partial success. And I do have some other images here. This one is the sum of my pilot's imaginary parts. So you can see it does quite wildly oscillate, but it does come close to zero at certain points. And here this is their cross correlation function. As I said before, for my first attempt I just did a cross correlation to find where the data stream starts, and then I run with that number. And what I do is I find the index of the maximum point of it. Now as you can see there are multiple maxima, which is going to give us an inaccurate starting position. And this is just our signal. It's a bit messy, but it's just so I can check to see if there's any large spikes of amplitude. So the other way that I was going to do it was instead of using just one cyclic prefix to do cross correlation, I was going to use multiple. So I have another function here that does that. So first we'll just run it so we can see what it does. Now I'm very surprised if this does work, because it's never worked for me in the past. and I'll explain why it hasn't worked and what improvements I would make if I had some more time. So as you can see here, as expected, we get 100% bit error rate. This is just randomness. It's kind of like an old CRT TV when you get an analog TV, it's just static. But what is of interest is these two graphs here. Now there's 100 spikes here correlating to the 100 symbols. As you can see, they're all pretty nice. If we zoom in a bit further, we can see they're a bit choppy, but we can work with them. And what I did is I smoothed these using a moving average filter, just so I could get like a nice sort of peak that I could run with. And now this is the coarse tuning, so the index of each maxima here, or 100 above them, correlate to the starting position of each symbol. So if we go back to the code, I can go over that with you. So the differences here are I'm running the cross correlation for the whole length of the signal as opposed to just over the first however many samples to get the first spike. And once I receive that C total, I plot that, and then I smooth it. And then I use MATLAB's built-in find peaks function, and this gives me an array that has 100 maxima and indexes, and I use this coarse index value. So once we do the downsampling and we come into here, I have my symbol start and my symbol end, and we need to downsample the index by 2, but I use the coarse index as the starting position. And this is only going to give us a rough starting position, so again I would like to use the pilot tones to further refine what I've done. But I did spend quite a lot of time on this, and I just couldn't really get anything to work. I've tried if the pilot tones are greater than 10, I delay, I can try advancing, but it never seems to work out. Again, just referring back to this, this attempt out again, I'm trying to do a live tune. I don't want to make multiple passes over the image, so sadly that didn't work out. But I do think this is the right way to do it. I do think getting 100 peaks and then doing some sort of live pilot tuning, that's the way you could get a live sort of real-time image decoded. So if I had a bit more time, I would probably focus on this, because I believe that the first way I did it, even though it produced better results, is a bit dirty. It's a bit cheap. I think this is the proper way to do it. But there also is a third option that I have been recently considering, and that has been to make multiple passes over the image. That is, I could, once I've worked out these indexes, I could then demodulate each image using that index, and then I could work out the best start using the pilots, and then I could go back to the beginning again and start again, and then run it through with these perfect starts, and I should be able to get a really good image. Now, the reason I didn't do that is because, referring to the diagram, is I was trying to do a live real-time reception, but I do see why you would use this other option of doing multiple passes over the image. Let's say, for example, there's a satellite that's taken an image of a galaxy far away and it's transmitted it to Earth, and we've received that data. We don't really need to decode it in real time. We could just make as many passes over the image as we want to, so we can get an accurate reception, which is what matters. So I could work a bit further if I had more time on doing multiple passes over the image, and I do believe that I would be able to get an extremely high reception percentage using that technique. But as I said before, at the start I made the decision to go with the live tuning. And if we go back to my OFDM assignment, we'll just try it with a different image, because as earlier on we recorded two, so we did the faces beforehand. So we'll try the office. And if you just give this a run, before we had a bit error rate of 71%, so hopefully we should get something quite similar. So there we go, we get a bit error rate of 74%. Now if you look here, again you see these nice horizontal lines. This is what I expect. This is what I'm expecting to receive. And up here you can see there's a nice big chunk. You can see multiple people's faces. Unfortunately the people to the right have been disappeared. Her face and body's in negative. But this guy here, you get to see basically his whole body and face, and you can see people down here. So I'd say that's quite successful. Again, looking at the pilot tones, you can see they are oscillating quite wildly. And there's our initial cross correlation peak, which is quite nice. So yeah, what I'll do in the future is I'll probably work more on my pilot tones, because the algorithm I've got is a bit cheap and dirty, and I don't really think it works that well. But I have put a lot of time into this, and I was expecting to get better results. I think personally, if I've had a better recording setup, I might be able to get a higher percentage recovered, because I think the shoebox and the cheap webcam microphone don't really help me. I think some proper audio equipment would